Hello and welcome to my shed. This is the third case study of 6 from the Book of Gold, and you may be wondering why I'm doing these presentations from the shed. Well, the shed is where I store all my precious bearings which I've stripped down over the year. The shed is where I do my practical work inspections, and as the Book of Gold is all about practical real life case studies, then this is the optimum place to do the presentation. So chapter 5 Section 1 is a case study today, is force brinelling on a pump motor. If you see behind me here, this is the actual bearing we're going to look at halfway through the preso. So it's a bearing 260mm diameter, rolling elements in the race. So it's a substantial bearing, and we're going to go through how, why and what happened in this case study. So basically JPS Reliability is a small consultancy business in the UK. What we plan to do, we're unique in that we enhance the system reliability through condition monitoring techniques. We improve machine reliability, we determine the failure mechanisms so then you can apply the correct technology and to drive the correct maintenance task. So condition monitoring alone does not improve reliability, it's just a tool of your whole tool set, which is part of the whole maintenance and reliability program. As you see, we've already got up online with RMS the first 2 case studies. This is number 3, force brinelling on a standby pump motor. So with all the case studies in the book, we have background and sort of failure line and analysis. So here is the pumps in question. We've got 2 pump sets. So whenever you go somewhere to do analysis, when you walk in there, don't just crack on, take your data, get out, go back to the office and do your analysis report, stand there, chat to the operators, talk about their problems, what problems they've had here, because 9 times out of 10, the operators know the history, they know their machines, they can be really helpful in guiding you to the best and the correct solution. So on this one here, I had a good chat with them, and you can see we've got a metal frame here. 2 pumps, and what's interesting, they go on these lovely short 90-degree bends which anyone practically wouldn't do into a single header. When I was discussing the problem with them, the header comes up and they've got like lagging around the flanges. So why have you got lagging around the flanges? Oh, the sills leak sometime. So straight away that's a red flag, so the pipes are moving to crack the sills to leak. And because you've got these MCCs and electrics in the room, they've put lagging around there, so when it leaks it drifts down the pipe. So straight away we can look at there and we can see an effect of a failure. Some vibration was causing this pipe to move and crack. They've been having pump issues, motor issues. Logically you go, well, it's on this metal frame here on some sort of project which they probably forgot to concrete in the base to make it stiffer. But alright, so we were called to this site, low reliability on the pump, so it's a metal frame. We have pump A and B. You can see this motor has been changed out because some repair company was changing it and it kept failing. And because it fell within the warranty period, they get getting smashed with warranties. So in the end, the repair company said, look, here's a brand new motor, we're off. And they went, because they just would be ever cycle repair and they didn't work out why this was happening. As I mentioned, the joint flanges on the pipe work were cracking and leaking. And also, a new pump end, the impeller showed off. So there's a lot of things going on in this set. So first thing is, once we scoped up, got the history from the operators, work out what's going on. We got an idea in our head. We think we know what the problem is. We took some vibration data. So this is the overall levels there. So you've got the increase in vibration there. And what we did, a very, very crude thing to stiffen the metal frame, we just wedged it with wood. As you wedged it with wood, the vibration come down. So straight away, you know that frame bouncing. And that frame, it's got the pump, it's got the motor, all the pipe work which is solidly bolted with no expansion flanges or anything. And that's obviously why they're getting the leak at the top. But by stiffening the base, we can sort of direct what we're looking for. We compared the 2 data from the 2 pumps. We had this pump here and pump B at 34.99 Gs. So that's pretty huge, and straight away with no history or comparisons, no history, you can compare it, the two pumps, and go, well, that one's no good, that one's okay. Looking at the vibration data here, so this is the peak view data. We can see here an outer race defect frequency, and we can see an inner race defect frequency. And what's lovely about the peak view data is that you can see this here, this lovely ring down. So with peak view, when you get a harmonic, an impact, a fundamental, and harmonics ringing down, then you know it's a nice ting, 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 clear defect in the data. But we've got outer race and inner race. So obviously, we got them to pull the bearing. From the book, this is pictures of the book here. You can see we go by failure mode, white fade and detailed images. So what we're going to do now is we're going to hop over and we're actually going to have a look at the bearing and physically see these marks in the bearings. Okay, we'll go there now. Okay, so we're now at the part of the case study where we're actually going to look at the physical bearing. So we've looked at the presentation, the spectral data, and now we're looking at the bearing. Just to recap, we've got our first book, Enhancing System Reliability for Vibration Technology. That came out in 2020. That was our first book, and basically it was my notes from over 20 years, my little black books, all written out in the way that I would understand, and I rolled into like digital form, and then someone said you should put in the book. Went to the book, we self-published just because we could, and it was actually quite well received. And the main bit about enhancing system reliability through vibration technology, the feedback was on the case studies. People absolutely loved the practical case studies because there always seems to be a lack of those in training courses and reference material. So this is where we came up with the Book of Gold. So the Book of Gold is our case studies from the last 20 plus years, all rolled into one huge book, about 118 case studies in there. That was published this May, and we are absolutely stoked at how well it's been taken up. We sent out initially 20 copies, limited edition 1 of 20 to 20 of 20 over the world to key personnel. Word got out, lots of good feedback, and many thanks to Reliability Maintenance Training Solutions, a training institute in the UK, because they were the first to actually take on the Book of Gold. They had initial allocation which sold out pretty quick. They're actually putting the Book of Gold on their public VCAT 2 courses. So if you go to the VCAT 2 courses, you'll get an amazing trainer, Dean Whittle. He is absolutely gold, he's so passionate. And as part of that course and the training material, you get your own copy of the Book of Gold, which is going to be amazing for reference material. Okay, so in the Book of Gold, we've already looked at the data. I'll just quickly show the book, the section it is in. So it is in section 5 pumps. So we got section 5 pump. This is the asset we were looking at. So you can see here, it's got the two pumps next to each other on a common metal frame, unfortunately, and they feed through to a common header system which comes out. So you can imagine the pump. So if one pump's running and one's not, obviously you've got your valve where the two pipes come together to go straight up to the vertical riser. So the pump's running, that will create pump vibration which transfers to the other pump, and that comes back to the motor, which is what we're looking at, the vibration data, the outer race defect. Again, we'll have the vibration data there, and the next page in the book, outer race, then the inspection of the bearing, which we're going to look at in a minute, and some microscopic images of the bearing. The giveaway for false brinelling is when you look under the microscope, as well as the shape actually of the element, you get these rusted oxide patches where the elements just sit there, and the vibration causes it just a sort of micro fretting movements, and that takes away the edge and that oxidizes. So yes, as I say, we're now going to have actually look at the bearing, which is in this case study. Alrighty then, so I'll show you the rolling elements first, and what's quite interesting on this one here, see it's not a small rolling element. So you can imagine these here in the bearing all the way around, and if you actually look at this bearing here, you can actually see, if you catch in the light there, where is it? There, you can see the shape here of the obviously where it's been stationary like that, and it's just been have that micro threading movements for a period of time, and that's where you get the surface-to-surface contact. There, see there. So that's a rolling element. Now, on the inner race, what would you expect to see? Well, across it we have actually got, there you go, see, small ones, larger ones, and it seems to be in the low zone, which is around here. We've got the deeper grooves there. So you've got those there, so you've got two there and there. So you can imagine actually spaced at the spacement of the rolling elements. And what would you expect to see in the outer race? If you've got the outer race here in the motor, which is stationary, would you see force brinelling all the way around? But you think about it, if the rotor's stationary like that, and it's got that slight micro movement, it's literally just going to be in a load zone. And the bearing's pretty huge, which is good because I can put it all around the camera. So if I find that there, here we go. So you can see there, nothing at all. Oof, there, see, nothing. Now if I flip it 180, so this is going to be the top of the motor. If we flip it 180 here, there we go. So there you can see force brinelling marks. Now you can see that there's like two groups of like a patches, a few. So that's the two rolling elements which should have been in the bottom of the bearing, sat there getting that micro movement. But you can see the rotor has moved very slightly for the elements to move there to give you different indents. So that's the bearing. You can imagine as well, what, 1500, 3000 RPM, it'd be like a train track, the noise that bearing was making. So pulling that out was the right decision, because that would have just spooled pretty quick and then cause a unexpected failure. So that's just having a quick look at the actual rolling out bearing. What we'll do is now we'll jump back into the presentation and we'll just go over the conclusion of why and what we found. See you in a bit. So, vibration analysis and phase, because what we did on this, because you got a motor, you can basically put two transducers and do cross channel phase. And if you put a transducer there and a transducer there, it should be zero phase movement. But if you put a transducer on that and then the transducer on the bed frame, and you watch your phase, as your phase changes, it would mean it's pulling apart. So you can mentally in your head get a picture, so you can map out the movement, so we can determine what the pump and base is doing. So we could say, well, the root cause of all your motor bearing failures, your pipe cracking, your flanges going, is because the base is too weak. So also one point to note on the pumps is when they come out, we had flow induced vibration, because when they designed it, in theory it might have worked, but in practical sometimes things don't. They had short bends, so as the water would go around the short bend, we get flow induced pipe work, strains, and obviously the pipe was moving like that. So in addition, we diagnosed the motor bearing defect, static indentation. So you imagine the spare pump sat there, the stationary pump's running. Because of the historical issues, operators don't like changing pumps. When it's running, they want to leave it alone because things keep breaking, which is okay, but they leave the one pump running and your stationary pump stood there. So that bearing here is from the stationary pump, the spare, the backup unit. So that stood there, and you can imagine all the vibrations from moving on the bed plate, the pipe's moving and it's transferring because the outlet of the pumps come together. That was given a static indentation. So our recommendations to resolve that was to concrete in the frames, add stiffeners up to the pipelet, and if they can, put in some sort of bellows, gusset, basically, just to absorb some of the motion, so when the pipe is moving, it's not going to transfer to the other pump. Well, thank you very much for listening. As I said, that was one of the case studies from our new book, JPS Reliability Limited, Book of Gold, Practical Condition Monitoring Case Studies. This is just the details of the book. Currently, as it stands today, which is early July, we've got 3 international stockists to try and help with reducing the postage costs We've got in the United Kingdom, Reliability Maintenance Solutions Limited, which is RMS training. In the USA, we have Nora Corporation, and in EU, we have Mark from 3PHI Reliability. There's our ASBM number there, our contact details, and like I said before, which is really good, and we're passionate about, and RMS is passionate because this book is actually free on their public VCAP 2 courses. So thank you very much for listening, and we've got another 3 case studies to do when we get some time. And go and get yourself a book of gold, and we hope you benefit and enjoy from it. Thank you.